Hi guys, welcome back to A Case of Econ Struggles. Welcome to another macro struggle. Today is part 2 of the overlapping generations model. And in this part, we're just going to solve what we set up last time. So let's go ahead and get right into it. Timestamps are below if you would like to jump around. But in this video, all I want to do are 3 things. First, I want you to understand why there's going to be no savings in the overlapping generations model as we talked about in part 1. So based on that, we can derive the optimal consumption when the person is young and old. We can also find R star. So that's the 3 things we want to do. And now let's just review part 1 very quickly. So again, in part 1, we had Bill in the OLG model. He lived for 2 periods, young and old, or working age and retired. He had income or endowment in both periods. You could think of that in any way that you wish in order to just understand he's got an endowment in both periods. We're going to have Bill choose consumption in each period, which is why he has C young and C old. He's going to have a utility function, U of something. And just for this video, to make it easy, I'm going to say that U is going to be the natural log of CTI, just so we can put a functional form on utility. I think it's going to help make it a little more concrete. And what we said Bill can do is that when he's young, he can buy assets or sort of like savings for when he's old. So he can buy them when he's young, he can cash them out when he's old, and have a little extra income when he's old. And so we can use that in order to sort of spread consumption. It's called the overlapping generations model, again, because 2 generations are alive at any given time, except for period 0, which is sort of a special case. So we're sort of ignoring that because when there's only 1 generation alive, you just eat whatever you got because you can't lend to someone who's not alive. So that's the family tree. That's why we have overlapping generations. If you want a fuller explanation, go ahead and see part 1 popping up in the top right corner right about now. And now we went back to Bill's problem. And the point of talking about Bill's problem here is now we're going to talk about why Bill does not save when he's young. Why he does not trade with an older person so that he can get some extra income when he's old. Well, his problem, again, he's going to max U of CY, which is now the natural log, plus beta natural log of CO, where CO is the consumption when he's old. CY is the consumption when he's young. He's got a couple constraints. The first is that when he's young, he gets an income, and with that income, he's got to eat it or save it. So that's what he can do in period young. When he's old, he gets the endowment when he's old, plus the return on his investments that he made when he was young. And again, I put this in parentheses last time. I think it's maybe a little confusing. So this is really R times A0. And then, of course, for Bill, over the course of his life, what he eats has to be equal to his income. So now that we've gotten that all straightened out, let's talk more about why there's no saving in the overlapping generations model as we've written it. So for this example, consider Bill the second and Bill, and we're at time t. So if Bill the second wants to borrow from Bill old, so he wants the assets to go this way, so Bill the second wants to borrow, so this is maybe Bill the second who's going to borrow, extra L there, so he's going to borrow. Well, when he repays in t plus 1, there's no Bill, because Bill is no longer alive. And because Bill is not going to be alive when Bill the second repays him, Bill the first does not want to do this, because he's like, absolutely not. I'm going to lend you some money today, and then when you would repay me tomorrow, I would be gone. So that doesn't make sense at all for me, so I'm not going to lend anything to you today. Now, if we go the other way, it's also not going to work. Because if Bill the old says, hey, Bill the second, I want to borrow some money for you today so that I can smooth my consumption a little bit. Again, Bill the old is not going to be alive in period t plus 1, so he's not going to be able to repay Bill the second. So here, in this situation, Bill the second is going to be like, no, I'm absolutely not going to do that. And those were our 2 options for borrowing and lending between the 2 overlapping generations, and we said neither of them work. And so because neither of them work, there's going to be no lending or borrowing between generations, and so there's going to be no assets being traded. So what's going to happen is that A0 is going to equal 0 for all t. Or maybe if you want to do it the other way, you could say really that AT0 is going to be equal to 0 for all t. No borrowing, no lending, because there's no way to repay the person who originally lent the coconuts, because the person who's going to repay is either going to be gone or the person being repaid is going to be gone because, again, you only live for 2 periods. You only overlap for 1 period. You would need to overlap for 2 periods in order for this to work, and they don't. They only overlap for 1 period, so we're going to have no savings. So now that we know there's no savings in the way we've written this OLG model, we can set AOLD equal to 0 because we just figured that out. And so since we figured that out, we can take this equation and cancel out the A0, and we can take this equation and also cancel out the A0, which means that the people in this economy are just going to eat their endowment. They're just going to eat whatever arrives on their door today because they can't smooth consumption over time because it doesn't make sense to lend or borrow in order to do that. And so we have sort of an incomplete financial market because we don't have assets so that we can take goods from one state or one time and transfer them into the next period. So notice that the interest rate can really be anything because the interest rate doesn't actually matter because if you're not trading assets, if you're not borrowing, you're not lending, what does the interest rate matter at all? It really doesn't. But we can still solve for R, and some problems still ask you to do that. And so I just want to go through how to do that. Well, we just sort of simplified our problem. And so what I'm going to do is if I think about technically that we could choose A, well, I can write CY and CO as just a function of endowment and these assets. And again, this R parentheses should really be multiplied, but that's okay. Well, now I can rewrite the problem like this, where this is CY and this is CO. And I have assets when I'm old, and so I can just take one first order condition, which is going to be this guy right here, and then set it equal to 0. And so remember when you're doing natural log, we have a minus up front because that's the chain rule. And then similarly, when we take beta natural log of this guy, it's beta over this guy times the chain rule. The chain rule gives us this R. We can set it equal to 0. And now all I'm going to do is algebra to figure out what R is. So I'm going to go through. I'm going to start doing some algebra. Again, I highly encourage you to try this on your own to see if the algebra makes sense to you. And so I'm just keep going. I'm multiplying both sides by beta times R. I'm getting this messy equation. I'm going to set it where I have the A's on one side. And I'm going to solve for A0 star. And the reason I'm solving for A0 star is because now I can use the fact that I know that that's supposed to be equal to 0. And I can use the fact that that's equal to 0 to solve for R. So I'm just going to do that. I can cancel the denominator. And I'm going to get that R star is 1 over beta times Y0 over YY. And all this means is that R star, the interest rate, is based on my patience level and my relative utility. And specifically, this is really R star is really 1 over beta. Y0 is the marginal utility when I'm young over the marginal utility when I'm old, which makes a lot of sense. Because my interest rate is based on how patient I am times the ratio or the marginal ratio of substitution between when I'm young and when I'm old. Because if I have a lot of consumption when I'm young, if I have a lot of stuff when I'm young, then my marginal utility is going to be really low. Maybe I'll write this out. So suppose that Y young is ginormous. It's huge compared to Y0. So Y0 is just kind of like normal. Well then, if I have a lot of stuff, my marginal utility when I'm young is going to be really low because I assume diminishing marginal utility. I don't actually have to assume it. The natural log function implies diminishing marginal utility. That was confusing. Also leave a comment. But so I have a lot of stuff when I'm young, which means my marginal utility is really low, which means that I'm willing to lend. Because if I have a lot of stuff, I'm willing to lend other people some coconuts because those extra coconuts are not really that worth it to me because I have so many of them. And so that's going to mean that my R star should be low because I'm willing to lend. And if I'm willing to lend, then I need a lower price, a lower payment in order to lend. Now, alternatively, maybe I'll do this in a light blue. Suppose instead that my YY was pretty low and my endowment when I'm old is ginormous. Well then, if that's the case, then my marginal utility when I'm young is really high because I don't have that many coconuts, and my marginal utility when I'm old is pretty low. So if my marginal utility for when I'm young is high, then that means I don't have a lot of coconuts today. And if you want me to lend someone a coconut, you're going to have to pay me a lot for me to part with that coconut today and wait until tomorrow to get an extra coconut. Especially if I already know I'm having a lot of coconuts tomorrow, I don't really need another coconut tomorrow. And so if you want me to lend that coconut today when I'm young, this R star, the interest rate you have to pay me, has got to be really big. And so that's sort of why this formula of 1 over beta times the marginal ratio of substitution makes a lot of sense. And hopefully it makes more intuitive sense now that I've sort of stepped through that. And so just to recap what we've done, we've shown that in this overlapping generations model that we consume our endowment, we've solved for R, but we know that R doesn't really matter because there's no asset trading happening in this OLG model. And so you might be saying, well, it seems sort of unfortunate that all these bills just have to eat their endowment and they can't sort of save across time. And so how can we make this better? How can we make it so that these people can save over time, that they can put some money away when they're young in order to smooth consumption between being young and being old? And the answer to this question is through government and fiscal policy. So we need to put some government into the model. And so part 3 is going to be where we put government into the OLG model, and we show how that can make this overlapping generations model better in terms of allowing people to smooth consumption over time. So if this was helpful, if you're excited for part 3, please like and subscribe. Please comment on this video. Please like this video. We'll see you next time for another case of econ struggles.